Alright, so this is going to be a quick video on how to get a soil moisture sensor working with your Arduino board or whatever microcontroller you use, ESP32, whatever. So this is the soil moisture sensor going to be used in this video. This is a capacitive soil moisture sensor, and also notice on there's a V2. There's some floating around out there that say like V1.2 or something like that, or V1 point something. I've had a lot of problems with those, so I would just stick to anything that either says V2 or just doesn't say 1 point anything. And I've had good luck with this one. It works really well, and it lasts a long time. So throughout life, you may come across a soil moisture sensor that looks like this, the one on the left here. I believe that is a resistive soil moisture sensor, and it is absolutely terrible. I've had really bad luck with it. They do work, but they only work for like maybe a week or two before they start going bad. They just get corroded and just stop working. So just make sure you avoid the ones that look like that. So I'll go ahead and get this stuff off the screen, and we'll get on with the rest of the video here. So this is the diagram that I'm going to be following. I'm not using any DF robot controllers or sensors, but this is the wiring diagram I'm going to follow that they have floating around out there. Basically, you have your 5-volt power wire, ground, and then we're plugging into analog 0. That's that first analog input pin. So I'll leave this up for a second so you can pause it and get your setup wired like this, and then we'll go ahead and go on with the code here. Alright, so the code, first thing we're going to do is we need to declare some stuff here, right? So let me get that going here. We're going to start with this. We're going to basically just make a variable called soil sensor, and we're going to come back to that. We're not going to use it right away, but we will use it later. The next thing we need to do is tell the board which pin we're going to be receiving information on, and you can call this anything you want. I just called it sensor pin, and 0 because we're going to be using analog 0 for our input. Alright, so for the setup loop, all you need to do is get the serial terminal going, because that's all we're going to do here. Is we're just going to get some valid data coming from our sensor, and then you guys can do whatever you want with it from there, but we're just going to cover how to get it working and reporting some accurate information. Alright, so our loop, our code that we want to continue running over and over and over, we're going to define a new variable here called sensor raw. So the difference between this and what we're going to do with this is the analog read function is it's going to read the raw analog signal coming from our soil moisture sensor, and depending on the board microcontroller you're using, different boards have different analog to digital converters, and some interpret information differently. These, the ADC, the analog digital converter on this board and most Arduinos it's gonna give you a value from 0 to 1023, and then if you're using something like an ESP32, you'll probably get a value of 0 up to like 4095, and those are just that's just raw information coming from the sensor that we can work with later, but this one's just going to give us 0 to 1023 is going to be the values we probably see here. But the next thing, well, before we get to the what to do with this up here, is let's just see what that raw data looks like, right? So let's just print out a couple simple lines here to just see what that raw sensor output looks like, and if it's anything we can work with, which it should be. So let's go ahead and upload this and see what we get here. Alright, great. see if we're getting anything in the terminal here. It's been doing this where I had to like open and close my terminal. Okay. So you see we're getting some good data here. We're getting this 600 number, right? But to us, we're like, well, what the heck does 600 mean, and how does that relate to soil moisture? So when I said that we're going to get a value from 0 to 1023, this is what we're seeing. So if you notice, when I touch the sensor, that value starts dropping, because the way this works is the higher the number, the drier the soil is, and the lower the number, the more moisture is that it's sensing. But we need a way to make this, in our case, a lot of people want to use this for measuring soil moisture of a plant that kicks on a pump or a light or something like that, right? So we want to get this into something that we as humans can read and do something with, like a percentage, like 0 to 100, right? That's kind of popular. So we're going to use something called the map function to actually normalize the 0 to 1023 values we're getting to a 0 to 100 figure that is like proportional to the numbers we're getting here, so we can actually make sense of it. So to do that, we're going to use something called the map function. And let me get that in here for y'all. Let's throw that in here. And this is where that value at the top, this, will come into play. So what this does is, this says take whatever that raw input is, and whatever you put here, this is the lowest, because remember, the higher the number, the drier it is, and the lower the number, the more moist it is. So we're saying the low end is 1023, the highest moisture level in theory would be 0, and we're going to say I want to map that from 0 to 100. So I don't want to see numbers from 0 to 1023. I only want to see numbers from 0 to 100. So let's go ahead and add that in so we can get a good reading and see if it's something we can actually work with, because we're humans and these ridiculous numbers don't make sense or tell us anything. Let me clean this up for y'all here. We're also going to throw a delay in there, like a second, because this thing's going haywire and it's just spitting out a lot of information faster than most of us can process it in our brains. So let's go ahead and upload this and see what we get. Just go ahead and clear all that junk out of there. Alright, cool. So here we have something that makes a little more sense to us as humans, right? So we see our raw sensor value is like 600 something, and that's showing up as 38%. And then if we put some pressure with our hand on the sensor, you see that raw value decreases, but the percentage increases, and that's what we want, because that's saying that there is more moisture being detected now with my grubby hands on it than is being detected when I take my hand off. If you notice, the raw sensor value goes back up, the percentage goes back down. So obviously, I'm going to put this code, I'll make it available either in the description, or I'll post a way to get to the GitHub where this will be, but this is just a quick video to show you how to get this soil moisture sensor working. If anyone wants to see me do something with this, like actually make it trigger a pump or a light, or or maybe even a whole plant watering project, just, I don't know, put it in the comments or something, and I probably won't do it anyways, but yeah, whatever. I guess that's all I got for this one. Yeet.